Welcome everybody to the American Space Museum as I'm looking way out there into the cosmos. Yep, I see Dave Stange up there in Michigan. All right, we've got Doug Forrest way over here in Los Angeles. And yep, there's one of the Usiak brothers. Tom's waving at me over there in Pennsylvania. Hope that you all had a great 4th of July weekend. I'm, of course, Marquette. Stargazer Mark today, as we're glad that you joined us to learn a little bit about stargazing from your own backyard. That's what we love doing at least once a week here on Stay Curious, getting you acclimated to those stars, the whole universe on your backyard. You don't really realize what it is. You can look at pictures of it from the Webb and Hubble telescope and be amazed. But once you go outside and kind of immerse yourself into the sounds of summer, the cicadas going, the insects. You hear a dog or wolf baying in the distance, all right? Maybe you're next to some water that you hear. Anyway, it's a gorgeous time to go out as we're all lingering outside in the summer, as the summer months keep us outside until maybe 9 o'clock, 9:30 when it starts to get dark. We just passed summer solstice, so the days are actually getting shorter and the nights longer. And we amateur astronomers love that. So we're going to talk a little bit about how to understand things in your backyard. When somebody says the International Space Station is coming high overhead tonight and it's going to be 60 degrees above the horizon in the northwest, how do you know how high that is and where you're going to look and so forth? Well, I'm going to put a few easy things in your mind that just makes sense to anybody. So that you can enjoy your app that you may have on your smartphone. Maybe you've got a map like I'm going to show you today from Sky Maps. There's the July map that's free to check out the constellations and all that's going on, and how to identify that light in the sky when you see it. So we hope everybody sticks around all week as we've got some great guests. I'll show them to you in a minute, but I want to say hi to Marty Winkel, my co-producer for 4 years in over 1,080 episodes of Stay Curious. And we've got Logan Cope. He is our intern from Eastern Florida State College. Logan, thank you for being such a faithful volunteer here, earning some credits at his university there. So he's running the board today, and Marty's overlooking his shoulder. And I've got my smart tablet on here. So if you got any questions or things, how can I bring that up? It'll probably beam up there live. Well, let me hit the live button. About backyard astronomy, what you're seeing, let me know there. As we're happy to talk to you here today. And we want to remind everybody, didn't put a picture of Karan Conklin up there, but our executive director, Karan Conklin, is at home getting some of her strength back. And we want to be keep her in her thoughts and prayers as she's battling cancer. There's my meme. I forgot to put anything up there today. That's the way Monday's going here, but had a busy Monday working on a couple projects around here, and hope that you all get your week of July off to a great kick. Here is the American Space Museum front that with our rockets out front there, the American flag waving. Hope to see you in here anytime. And if you're looking for ways to contribute financially, go to our website, and we're happy to take bushel baskets full of $100 bills to sustain our nonprofit. And our guest this week, we have got Ken Joseph, who have not met but talked to on the phone. He's a budget technician liaison, he calls himself. He's involved with the money, but he's not just like a configuration management person. He is involved with the technicians and working with them, as I understand it, what kind of money they need. He's been around 30-some years in the shuttle program. We look forward to Ken Joseph tomorrow. Mike Chinelli, our NASA lessons learned from Apollo, Challenger, and Columbia, will be making his second appearance on Stay Curious. If you have any questions about what they've done with the Columbia or Challenger structures, he can answer those questions, but he is actually a NASA out of Washington, D.C. employee and here at the Cape. And we enjoy building a bridge to Mike. He's anxious to tell you some things that are going on, and he wants to come on once a month, just like our friend Terry White, the shuttle chief garage mechanic there. He's going to be talking about some of the shuttles of the month of July, as well as some of his experiences. And one of those experiences, Marty, for the last time, a space shuttle lifted off a launch pad 13 years ago on July 8th, 2011, when Atlantis was blasted off with a crew of 4. We put that on our Facebook page there. We'll probably talk about that tomorrow, as we want to focus on backyard astronomy today and things that you see in the sky. Wait a minute. Let me see if I can see all the way to Georgia. Yep. There's Gary Gerald getting off his tractor up there in Collins, Georgia. And I'm sure his wife Donnie's got a great meal planned for him tonight. And he's maybe seen these things when he's visited on the Atlantic Ocean here. We're looking at the Atlantic Ocean, and you sometimes see these sun rays, I'll call them, go across the sky. But this is a very special one because this sun ray came behind us. All right, the sun setting behind me, or the couple walking across the beach there. And this is actually called an anti-crepuscular ray. All right. And it goes all the way across the sky, over 120 degrees to illuminate the eastern sky there. So you don't see that very often. But we're going to encourage you to get a sky map at anywhere. Bookstores have sky maps. A lot of nature centers will have sky maps, or anything you buy that if you use it by getting out in the night sky underneath the stars, you will see most of these stars here. You're not going to see the outlines. That's what is challenging of everybody, is creating a Hercules man right there in the center. The square is they call it the keystone, and the arms coming off it are stars, you imagine. I think it looks like SpongeBob SquarePants. And over here's Bautes, that the ancients said was a herdsman. It looks like a kite or an ice cream cone. Up here is the Big Dipper, just part of Ursa Major. The pointer stars are pointing to the North Pole. And the blue is the Milky Way. So this is depicted for early, around 10 o'clock at night in early July, or about 9 o'clock in late July. So by 10 o'clock, the Milky Way is very visible, and you can just catch a hint of it from your urban backyard, all right, as I did last night looking at it up there. Steve Jokum says hi. Great to see you, Steve. He says hi to Mark, Marty, and Logan, and all the Stay Curious gang from Lake County Spaceport. He's up there in Fox Lake, Illinois. Yep, there he is. I see him up there, Steve. And we love that he participates every week with our almost every day. And Tom UCX says, looks like we've got a nice lineup this week of guests, and we certainly do. And thank you all for wanting to see those guests, as I enjoy kicking back and hearing the stories they got to tell. Well, the star maps are important. This skymaps.com has a lot of great information on it, and every star map kind of has a magnitude scale on it. And as I make this smaller, you see on the bottom right there, they have a magnitude scale where the brightness of stars, the bigger the stars depicted, the brighter it is, which makes sense. And that's how you kind of zero in on the handful of bright stars. Sadly enough, your backyard, you're going to be lucky to see all year. And at any one given time, you'll be lucky to see 200 stars from your backyard at any one time. Those are all the stars that are down to about third magnitude. The lower the number, the brighter the star. So first magnitude star, the summer is filled with a lot of them, and those are the bright ones that have the bigger dots, if you will, like Arcturus there. All right. And those are the signposts. You can create your own constellations, make the dots any way you want. All ancient civilizations have, even modern ones. No one owns the original. You can go out there and do anything you want with the stars. But how to identify that light in the sky, all right? Well, this is kind of silly, but it's also kind of a lot of fun. The first yes or no question is it really big? Now, they really mean bright there. Is it really bright? And if it's really bright, yes, it says, are your retinas burning? Are your eyes burning? If they're yes, then it's probably the sun you're looking at, and quit looking at the sun through binoculars. You're going to go blind. Don't ever do that, or a telescope. But if your retinas aren't burning, then that's the no question. You're looking at the moon. All right. And then we go over, is it moving? All right. And here's where you start defining things in the sky. Is it moving? And we'll go through that here in a little bit, so stay curious. As again, the magnitude of things in the sky is an arbitrary scale of magnitude. And it's a logarithmic scale that the ancient stargazers, this came into vogue more about like 250 years ago in the 1700s. Some of the cartographers of star patterns had to have a scale to say how bright they are, so they came up with a scale of magnitude where first magnitude is 2.5 times brighter than second magnitude, that's 2.5 times brighter than third magnitude, that's 2.5 times brighter than fourth magnitude. It's a logarithmic scale. So a first magnitude star is 16 times brighter than a fourth magnitude star, and the handle of the Big Dipper, of the Little Dipper, has a couple stars that are hard to see, and those are fourth magnitude stars from a backyard. All of the handle of the Big Dipper and its the Big Dipper's bowl are second magnitude stars, and one of them in there is third magnitude. So that's the scale. It's a logarithmic scale. It's arbitrary, but wait a minute. Cut to the chase here. The brightest stars are brighter than first magnitude. So 0 magnitude they created is 2.5 times brighter than first magnitude. And then there's a negative scale of -1 is 2.5 times brighter than 0, which is 2.5 times brighter than +1. We'll see that clear as mud here in a minute. But if there's mud in the sky, there's nothing clear to see. So, but it's just a way of we communicate to talk like an amateur astronomer. Is there's a comet in the sky and it's fourth magnitude. Your chances of seeing that without binoculars anywhere in an urban area are really slim. Not impossible. Sixth magnitude is the faintest seen by the human eye, and that's 100 times fainter than first magnitude. But sixth magnitude on a dark mountain, desert, you can see down to that, but it's going to take a dark place to see it. Now, the other thing we're going to talk about in the sky is degrees, all right? Degrees in height, degrees across the sphere. This is not temperature degrees, not like we're always talking about it's in the 90s here degree-wise Fahrenheit in here on the Space Coast. So when I say that the International Space Station is going to appear, you look on your application and it says the ISS will be visible at 8:50 tonight. It'll be seen 10 degrees above the horizon, north-northwest. In its highest altitude, it'll be 66 degrees above the sky, up in the sky. How high is that? Well, in your mind, you're going to say 66 degrees. That's pretty high up in the sky, and this illustration shows it. But you can think in your mind where that 66 degrees is with a little help from, that's right, the old trusty protractor that you had to buy at some point in time in school to learn your geometry. So this is just like the dome of the night sky, all right, where, see there's the dome, there's the protractor. So directly overhead is 90 degrees, all right? From horizon to horizon is 180 degrees total. So if the sky, you say that the International Space Station is going to be 40 degrees at its highest point above the sky. You see on the protractor the 40 degrees there, or 66 degrees. You see the 66 mark there, and we go back, and it's quite high up. So anything 45 degrees is going to be from directly overhead to the horizon. It's going to be right in the middle of there. That's 45 degrees. So if it's 40 degrees or 30 degrees, it's going to be below, halfway up above the horizon and directly overhead. See that with the protractor. If something's going to be 90 degrees overhead, wow, that's directly overhead, and it's going to be really bright, and it's going to be really long past the International Space Station, because the higher up it is, the closer it is to you standing on the globe, as it would be directly overhead. Now, we don't say anything's 130 degrees. They just go, it would actually be on the other scale there, like 40 degrees up from the western horizon. So keep that in mind when you're talking about things there. Hi, Carlton Bailey. He's real close. He's over there in Cape Canaveral Groves there, sweltering on another hot, humid July day, just like we love it here on the Space Coast. So now, one thing I talk about a lot when we talk about the moon is the moon is half a degree across. Your little finger outstretched is 1 degree. You're going to see that in just a minute. So if it's a half a degree across, that's right. From the horizon to directly overhead, 180 moons you could stack end to end to end. And then 180 on the other side. That's incredible to think about when the moon looks so big in our minds, but it is only a half a degree it covers up in the sky, whether it's full, first quarter, supermoon, regular moon. From directly overhead to the horizon, 180 moons could be stacked end to end, and then 180 on the other side. Isn't that amazing to think about? Here is the way you use the human body, which is anatomically the same for all humans. That's a unique thing, is that whether you're 6'8" or 5'8", your arm length on normal people are a ratio, all right, there. And so your little finger outstretched is 1 degree across. 3 fingers across are 5 degrees. 5 degrees is the pointer stars here of the Big Dipper. All right. So if I say later this week, we're going to be looking at, according to my sky maps here, that annotates a lot of things, Jupiter will be 4.8 degrees north of Aldebaran in the morning sky. So it's going to be the distance, the moon to Aldebaran, a bright red star, is going to be the distance of the pointer stars of the Big Dipper. The Big Dipper, look north, it's going to be on the left side of Polaris, the North Star. Let's see, Mars is going to be a half a degree near Uranus on the 15th in the morning sky. Later on, the moon is going to be 15 degrees from Saturn on the 24th, and so on and so on. So it's important to talk degrees. Your clenched fist is 10 degrees. That's across the bowl of the Big Dipper. All right, rock and roll sign there, okay, which my arthritic fingers can hardly do, is 15 degrees across there. So, and from finger tip to thumb is about 20 degrees. So once again, you can use the Big Dipper in your hand to understand direction in the sky, and it's important. Well, let's identify a couple more things in the sky. You're outside, you see something moving, all right? Now, yes, is it moved so quickly you almost missed it? Well, if you can say yes to that, all right, then we go down the left side. Is it extra super bright? Yeah. And it ended, did it end? If it's extra super bright, nah, not super bright, but boy, it flashed so quick. That was just a regular meteor right there, all right? But if it's super bright with a dramatic explosion at the end, all right, and that's my name down there. Take my name off there a second. There we go. Thank you. That's bolide or fireball. And that's what Logan chose for our backdrop today, is this is what you call a bolide or a fireball. A bolide actually blows up and you kind of see not the shrapnel of it, but you can tell it blew up. A fireball doesn't explode, but this is probably the size of maybe a 1-inch piece of rock, gravel, if you will, and it burns up in the atmosphere real quickly, and when that compressed atmosphere makes it explode at the last second there. This is actually going through Orion the Hunter, those of you that recognize the 3 stars of the belt and the sword dangling down. It's going between Rigel and Spica there, or I mean Bellatrix and Spica. And on the left, that bright star, that is the brightest star in the sky, Sirius. It is minus 1.5 magnitude, all right? The stars of the belt, the 3 stars near there, they are all second magnitude. So look how much brighter Sirius is next to the second magnitude there. Let you take that in while I get a sip here. By the way, I hope you're all enjoying my arse hat here. My arse hat, that is the Australian Research and Australian Research and Scientific Exploration. That is their NASA, and it's called ARS. And thank you, Cliff Watson, who gave me this off of his head to mine. There it says right there, just like I said, Astronomical Research and Space Exploration. That's their NASA, and they call it ARS. You Australians or something else down there. They're experiencing winter right now while we're getting hot. Thank you, Cliff Watson, for watching us and staying curious all the time. Well, so that's if something moves real quick in the sky. It's either probably going to be a meteor or a fireball or a bolide, particularly if it blows up right away. Well, the next thing on our chart here is it moving? All right, over there on the right. Is it moving? Okay, I'm saying it's still moving. All right, is it blinking? That's the first thing you want to look at. Does it have multiple lights on it? Is it blinking? If it is blinking, then it's probably an aircraft. An aircraft have a white light, a green light, and a red light. Tom Usiak knows where those lights are. I think the red light's on the top of the rudder, and the white lights on the wings, but they'd be blinking and moving, all right? And we see that all the time because we're so close to Orlando around here, and it's fascinating to watch some of these planes come in. So if it's blinking, it's an aircraft, all right? Now, if it's not blinking, you have to ask, is anybody waving at you? Okay. And if no, then it's an artificial satellite, all right? But they usually don't blink. All right, they will get brighter and less bright the higher up they go because they're catching less sunlight on their solar panels or wherever is reflecting that. But if somebody's waving at you, that's the International Space Station. Of course, you're not going to see anybody wave at you. But the International Space Station will be bright. It'll be as bright as a first magnitude star. It will be one of the brightest stars in the sky for sure. And they'll be moving very steadily. And your app says 10 degrees above the horizon is when you can first see it most of the time. So how much is 10 degrees? Well, at 3 fingers, I've stretched is 5 degrees, and a fist is about 10 degrees. So you go outside, look where it's going to be, put your fist up, that's 10 degrees above the horizon. 2 fists is 20 degrees, all right? Use your head, and you can about figure out where to start looking for these. The space station, Tiangong Heavenly Palace is visible of China. I've seen that. I've seen the Hubble telescope is pretty easy to see, though it's 4th to 3rd magnitude, so you kind of need to be in a dark spot. 3rd magnitude is about the faintest you're going to see in any urban backyard. Now, let's get back to our thing here. Is it moving? Well, if it's not moving and it's bright, you want to ask, is it twinkling? Generally, stars twinkle, planets don't. Why? Because planets are reflected light and stars are pinpoints of light. And it's how they hit the atmosphere makes them really twinkle, not the star themselves. It's like looking at an aquarium or water, and you see the water moving, and you see what you're looking at in the water is changing shape. That's what the twinkling's all about. Well, if it's not twinkling or barely twinkling and it looks kind of fuzzy, all right, then you put binoculars on it and it looks like a dust bunny under your bed, that's a comet, all right. Get your camera, put it on a tripod, take a 30-second exposure. At the night mode, you're going to see a comet tail up there a little bit. And we have comets periodically in the sky. There's a couple going on right now, but nothing that you're going to see without a lot of effort. Another thing that's moving across the sky, across the water, or low to the horizon, if you see something moving that keeps moving parallel to the horizon, guess what? That's a boat. That's the masthead of a boat. All right. But if it's not fuzzy, no. And it's not a boat, it could be a planet. And the planets are generally over second magnitude. Mars is about second magnitude right now, but later this fall, it'll be close to first magnitude, and next fall, it's going to be close to Earth, and it'll be a whopping minus 2 or 3 on the scale there. Super bright. So that's a little way to identify that light in the sky. Hope you enjoyed that. A little bit of detective work like Columbo would do. And if it keeps circling around and bright lights are flashing on you, all right, you're either in trouble with the law or you're going to be abducted by an alien. So either way, just surrender. So what else can you see in the sky? There's the Starlink Satellites. This is a time exposure of about maybe 10 seconds where you see them moving. It's probably 30 seconds. They move kind of slow across the sky, but they're the same brightness. There's 1, 2, 3, and then 2 in the tree there. Starlink Satellites that I photographed a while back. Just going lazy through the sky like finger paint. See, you're opening up the shutter, and that also allows the fainter stars to be seen and the trees and so forth in the darkness. There's that bolide. Once again, the scale limit of magnitude. All right, so if I said the brightest star Sirius is about -1, Venus at its brightest is always the third brightest thing in the sky, and it's just below -4th magnitude, all right, which is almost 100 times brighter than first magnitude. The full moon is around 13, 14 magnitude, and the sun on this arbitrary scale is -27 magnitude. Now, the Hubble Space Telescope can see down to about 28th magnitude, very faint. The naked eye limit is 6th magnitude, as you see there. Polaris, the North Star, like we talked about, is 2nd magnitude. So there's a little bit of yin and yang there of what you're going to see in the sky. How bright is it? Well, it was 1st magnitude. That's very bright. If I said how bright was it? Well, the space station is only going to be about 3rd magnitude. You're going to have a hard time seeing it in your backyard unless you know where to look. And when you do, throw some binoculars on it, and that'll really bring it in bright. Well, the moon. To talk like an amateur astronomer, how many days old is the moon? Okay, and you start with new moon is 0, and that was on the 5th. So today being the 8th, the moon is 3 days old. Now you're going to see it as just a crescent in the moon. It's going to be so cool. It's going to look, Dave Stange is going to go out and see it in Michigan, and that crescent fingernail moon is going to look like it's like your fist couldn't cover it up. But take your little finger, extend it, and you're going to cover it up all the time. It's only a ½ degree apart. 7-day-old moon we're going to have on Saturday. That's first quarter. 14-day moon, that's full moon, and that'll be the following Saturday, the 21st, which will be Moonwalk Week, as July 20th will be the 55th anniversary of Apollo 11. And you better believe next week we'll be talking a lot about Apollo 11. And so I'll try to get some guests lined up, or even cajole Marty here a little bit to talk about that fabulous lunar module. Don't know what I can cajole him with because he's got everything, but love to, maybe we've had all the grummies on here, and quite frankly, I'm not sure any of them's got any energy left in him, Marty, to talk. God bless him, but we'll be talking about Apollo next week. Not only do you have degrees of the sky, but you've got a coordinate system there that equates to Earth latitude is the declination. That's up and down the sky, like Earth's latitude. That's declination in the sky. So Polaris is at 90. The lower the number, the closer to the equator you are. The celestial equator and everything on the Earth is just like thrown out from the Earth up into the sky pattern. That's how our road maps are created, to know the coordinates. The longitude lines become hours as 24 hours things circle around. So over here, you see that 23 hours in 80 degrees is the top of Auriga, a constellation there. The Little Dipper, well, there, let's look at the Big Dipper on the right-hand side. Ursa Major, the one star of the handle, Merrick, is 13 hours and 55 plus 55 declination at 13 hours. You see what I'm talking about right above my head right there. So this is how astronomers talk, mostly the professionals, about where they're finding things in the sky. And again, don't forget your outstretched little finger is 1 degree. You can't, it's different when you get it close to your eye. You have to have your arm stretched out. 3 fingers, the old Boy Scout peace sign, is 5 degrees. Your fist is 10. Move your fingers out for 20 to 25 degrees. And again, the number of stars that you can see up in the sky at any one time, usually there's 1 star at minus 1. As far as 6 magnitude stars, you can see about 3,000 in one night on a desert. All right, but 3rd magnitude stars in the sky, you're going to be lucky to count 120 stars in your backyard. But they can all be milestones and guideposts to find other things. After all, stars are like human beings. They're different sizes. Some are different shapes, but basically the age of them is different. And we know now that most stars have worlds going around them, like our planetary system. So we're winding up here. One little complex image to show you there again of the apparent magnitude, the full moon, about minus 13, Venus minus 4. The brightest star in the sky, Sirius, is minus 1. So you've always got the sun, the moon, and Venus will always be the 3 brightest things in the sky. They're the sun at minus 27, always. Nothing will ever get brighter than Venus. Once in a while, Jupiter is close to 2nd minus 2 magnitude, and Mars will get that when it's close to Earth. So you go outside and you see the sun setting and you see this gigantic shadow across the sky, and it's breathtaking. What's going on here? Well, the sun is set behind these clouds, and the clouds are creating a shadow in the sky. Everything creates a shadow from a point of light. So these are actually the shadows of these clouds here projecting up against the alto cirrus clouds in the sky. That's awesome to see. And then it goes all the way across the sky, because I'm looking to the west, and in the east, that becomes the crepuscular rays. See those rays there, dark rays there? This is part of this same system that reached all the way across from the west to the east. And those are called anti-crepuscular rays. So much to see in the sky with your naked eye. How about one of my favorites, the Belt of Venus? The Belt of Venus is this pink atmospheric line that you see when the sun sets, all right? It's caused by haze in our atmosphere. But what's this black, dark area here? Not black, but that dark grayish area? That is the Earth's shadow creeping up into the east as the sun's setting in the west. The sun is below the horizon, so the Earth's shadow is actually cast against the lightness. And then half hour later, you don't notice it because it's in the sky, and of course you can see your shadow. You can see things through your shadow, so you see the stars through the Earth's shadow in the sky. But that's called the Belt of Venus, named not after the planet Venus, but named after the belt that the goddess Venus wore across her chest. That was a name for a brazier in Greco-Roman times. 2,000, 3,000 years ago. So a belt had many connotations, not just around your waist, but a sash to be worn around the chest. And so the belt of Venus is sort of the bra of Venus. But the belt of Venus encompassed and secured around the landscape. And I love looking at that. Now you're going to see it tonight, wherever you're at up there. You got John the Beagle Dad's watching. All right, glad that you're staying curious. Steve Jokums will go outside Illinois and watch this belt of Venus tonight. All kinds of astronomy without the telescope, and I love that. Here are the clouds. That's actually Orion over the Kennedy Space Center Visitors Complex there. Meant to throw some summer pictures in there, but didn't. And satellites, yes. Here are satellites crisscrossing the Great Globular Cluster of Hercules. Quite a famous thing to find in the sky, directly overhead. It is on this skymaps.com that you can watch anytime on there. Thank you, Logan, for pushing that up there. Right there in the middle, and there's a little globular cluster, and you can see that like a faint little dust ball in binoculars even. There's some adapters you can buy to put on the front of a binocular, by the way. Every binocular, you peel off this cap, and there's a screw there. And you can screw that in there, and then a little piece comes down like this to fit in a tripod. And that's how you keep steady there. Andrew Oliva might be watching and knows that. How about Howard Pepper? All right. And Hilda Hanks is watching. There's Hazel Banks. I see Hazel Banks watching just not too far from us in Merritt Island. So let me get my star map there as I'm ending our program today with these satellites. That's what's fun of going out into the evening twilight, sitting back, enjoying your beverage with your binoculars at hand. You're going to see things streaking across the sky all the time. Satellites will be going in a straight direction. They won't adjust. They'll change their brightness when they get higher in the sky and they're not being hit by the sunlight. Those going north and south are probably spy satellites. But we've also got this communication system going of the Starlink satellites, and you might see some of those. And there's an app for that for your wonderful cell phone that you can download things and see what's going on in the sky right from your backyard. This again is a photograph where a friend of mine left their lens open for about a half an hour, and these are all the satellites that came by. All about 6 magnitude, maybe 5th or 6th magnitude, right at the threshold of where you can see it there. So hope you've all enjoyed a little backyard astronomy. Tell your friends that this is where you get to know what's up in the night sky and understand a little bit about some of the physics of our world that keeps us going. And we're glad that everybody shares this where they can, because we want you to get out in your backyard, turn that TV off, enjoy a little bit of starshine. And then as the moon's coming around this week with a beautiful crescent in the sky, we're going to be getting some moonshine. So go and enjoy it. That bright moonshine will drown out all but the brightest stars. So this week is a great time to even see that beautiful Milky Way as it goes overhead. And I'll be talking about everything in the sky that you can see with the aid of binoculars. We're not even going to talk about telescopes. Most everyone's got binoculars, or just your beautiful eyesight. So until next time, and we've got some guests I want to remind you of. There's our guest there. We got Ken Joseph tomorrow. Going to talk about the money end of the space program. Mike Chinelli, he's involved with that beautiful display out there next to Atlantis, where we honor our heroes of Challenger and Columbia accidents. And then Terry White, who not only lived through those accidents, but lived through the end of the shuttle era 13 years ago this week. Terry will have some comments about that, I'm sure, as STS-135 was launched, the last shuttle ever of our 135 launches over 30 years, launched on this date, July 8th, 2011. So until next time, I'm Marquette, saying I can't wait to see you in the museum to bridge the space between us. And let me look at y'all out there. All right.